Hello, Pre-Calc. Happy Wednesday. Today we are going to be starting section 6-3. This is going to be the first day of it, and we are doing systems of equations. Which you learned way back in Algebra 1. I think you review it in Algebra 2 maybe a tiny bit. So systems of equations are awesome, used all the time. And, oh, actually, I used one in an escape room, like, on multiple occasions. And so you can actually use matrices to solve a system of equations. So you guys are used to graphing, elimination, and substitution, but you can also use matrices. And it's really helpful and pretty quick to do. So we're going to focus today on solving a 2x2 system. And we are going to be doing it by hand, which means you need to be showing a certain amount of work. So the very first thing you need to do is write your matrix out. So we're going to write the system of equations in matrix form. Which is going to be a matrix A times our variable matrix X, and it's going to equal B. That'll make more sense once we start to do an example. The second thing we're going to do is find the inverse of A. And then you need to multiply the inverse by the system. Which should make sense. So we currently are going to, or you're going to start with AX equals B, and remember you can't just divide by matrix A because you can't divide matrices, but we can multiply it by the inverse. So you're going to multiply the inverse on both sides. What's important is it's going to be on the left because the order matters. On the left side, you're left with the identity matrix equals X, which is perfect because then we get our variables by itself. And then on the right side, you're left with the inverse of A times B. And then this is what is important, and you're going to have to show that. And then the fourth step is just to write your solution as a coordinate point, just like you did back in Algebra 1. Because the solution to a system, remember, a system of equations are two equations that have a coordinate point where they intersect. The coordinate point is the solution. So you're going to write your solution as a coordinate point. So we're going to do one example together in a U-try. So our example. Using matrices, solve the following system. 6x plus y equals -8 and -4x minus 5y equals -12. So the very first thing we want to do is write out our matrix in the form AXB, and I would like you to label that. So what that's going to look like, matrix A is going to be the coefficients on the left-hand side. So first of all, before I keep going, we want them to all be in order. So notice we have x plus y, the equal sign, and then our constants. This is the specific order we need it to be in always. If it's not in that order, there's a secret first step, and that's rearranging it. So our matrix is going to be 6, 1, -4, -5. So that's our matrix A. Our matrix X that we multiply it by are the two variables we're working with. So up top we're going to have X and then we're going to have Y. So those are the variables we're solving for. And then that is going to equal B, which is a 2 by 1 matrix, the constants, -8 and -12. So that's matrix B. So we want to multiply by the inverse of A so that we can get X by itself and solve. So what that is going to look like, we need to find the determinant. So the determinant of A is going to be, remember, the diagonals minus the multiplying of the diagonals. So 6 times -5 minus -4 times 1, which is -30 plus 4, which is -26. So then the inverse is the determinant, 1 over -26 times the matrix, and then we do some swapping. So this is -5, -1, +4, 6. So that is going to be positive 5 over 26, positive 1 over 26, 4 over 26, which reduces to -2/13, because that's a -26, and then 6 over -26, which is -3/13. So that is A inverse. So now the next thing I want to show, and so far all of this is required. I guess maybe if you did the determinant in your head, that's fine, but it's a real risk. You don't want to make any mistakes. So now that we know the inverse, I'm okay. You don't have to show all of this, but I do want to see this set up. So you're going to have X equals the inverse of A times B, and the inverse needs to be on the left. So that means X. You can either write X, or if you want, you could rewrite this as the matrix it is, which is X, Y. So the inverse matrix is 5/26, 1 over 26, -2/13, and -3/13. And I'm multiplying that by -8, right, and -12. Cool. So I'm going to take the first thing, multiply it, and add. So that's going to equal 5/26 times -8 is going to be -40 over 26. Now, here I would not reduce. Plus -12 over 26. And here's why. We have a common denominator, which is awesome. That doesn't always happen. You'll have to get one if you don't have one. But that just makes it a lot easier. Alright, so then we have -2 times -8, so 16/13 plus 36/13. That becomes positive, which is nice. I'm going to rewrite this so that it lines up well. Okay, now I'm going to add. So -40 minus or plus -12 is -52 over 26. 16 plus 36 is 52 over 13. And those are my x and y values, except they can be simplified, so I must do that. And then I'll show you what students do wrong. So negative 52 over 26 reduces to negative 2, super nice. And 52 over 13 simplifies to positive 4, also super nice. Which means x is equivalent to negative 2 and y is equivalent to 4. And because this is a system of equations, I must rewrite this as a coordinate point. If you don't, you will not get full credit. So, recapping, rewrite this, ax equals b, label that, determine your inverse, so you need to get the determinant and multiply, then set up x equals a inverse times b, show your work, use matrix multiplication, and rewrite your final answer as a coordinate. So now I'd like to do a U-try. So I would like you to solve this system. 2x plus y, I'll keep it easy too, equals 436. When I say easy, I mean I'll keep everything lined up. 3x minus 2y equals 192. So I'm going to do it a little bit different. Usually I go through the whole problem. I'm going to pause the video and do it step by step and then show my work. So I would pause if I were you and try to do this entire thing on your own and then hit play to go over it. So the first step is to set up your ax equals b. So that's going to be 2, 1, 3, negative 2 times xy equals b 436 over 192. So if you're checking piece by piece, that is ax equals b. The next thing I want to do is determine my inverse. So I'm going to pause and then do that. Okay, so I determined the determinant is negative 7 and used that to find my inverse matrix. Now what I'm going to do is multiply the inverse of a times b. And then I'll be left with my solution. Hopefully you got 152 for x and 132 for y. So I know a lot of you guys just care, okay, well what do I need to show? So required work, you need to show me this whole first thing of setup. I won't require the determinant, but I really think you should. I am going to require, obviously, your entire work for A inverse, which means yes, the multiplying, and yes, the final answer. Setup and answer are both required. And then I want to see the setup, and I want to see what you're adding together. If you jump to the final answer as a matrix, that's fine, but you must also write it as a coordinate point. So these problems, you have to show a lot of work to get full credit. So as always, if you have any questions, please come to Flex Time, and I hope you have a great day.